picture this. 4 astronauts sitting inside a spacecraft, drifting silently through deep space, farther from Earth than any human has been in over 50 years. Behind them, the Moon. In front of them, a small blue dot, Earth. And inside their system, cameras are capturing something historic. Not just the journey, but what they are about to bring back. Because this mission was never just about going to the Moon. It was about what humanity would see when it came back. For decades, the Moon was considered done, a place we had already explored, a destination checked off the list during the Apollo era. But that assumption turned out to be wrong. Because Artemis II was never designed to repeat history, it was designed to redefine it. This mission wasn't about landing. It was about testing everything under real human conditions before we commit to something much bigger. And when those astronauts returned, they didn't just bring stories. They brought back a completely new visual understanding of space. These are the people at the center of it all. Reed Wiseman, Victor Glover, and Christina Koch, and astronaut Jeremy Hansen. Highly trained, carefully selected, years of preparation, all leading to one mission. But what makes this crew different is not just where they went, it's what they witnessed. Because for the first time in decades, humans were sent beyond low Earth orbit into deep space with modern instruments. And that changes everything. The journey began with one of the most powerful rocket launches ever attempted, a controlled explosion of energy lifting a human crew beyond the atmosphere. Within minutes, they were no longer part of Earth. They were on a trajectory that would take them hundreds of thousands of miles away. This is where things start to change. Because once you leave Earth's immediate environment, space behaves differently. Radiation increases, communication delays grow, systems are pushed harder, and every second is being recorded. Inside the spacecraft, every moment was monitored. Every movement, every system check, every signal. But something else was happening too. The crew began documenting their experience visually, not just scientific imaging, but human perspective. What space looks like when you're actually there. And what they saw was different from anything recorded before. As the spacecraft moved farther from Earth, cameras turned outward, and this is where the first major visual shift happened. Earth began to shrink, not metaphorically, physically. Frame by frame, it transformed from a detailed world into a glowing sphere, into a distant light. These images are more important than they seem, because they show something we rarely experience. Distance. Real, measurable, visual distance. And it changes how we understand our place in the universe. But the real moment came when the Moon entered the frame. Not as a symbol, not as a concept, but as a world. As the spacecraft approached the Moon, imaging systems captured the surface in extreme detail. Craters stretching for miles, shadows deeper than anything seen on Earth, textures that looked almost unreal. But here's what surprised scientists. Some regions reflected light in unexpected ways. Subtle differences, but consistent. Especially near permanently shadowed areas. These variations suggest something important. The Moon is not as uniform as we once believed. There are differences in composition. The crew witnessed something else, a fading world, not rising, but slowly slipping away. As the Moon moved into perfect alignment, it began to block the light, an eclipse unfolding before their eyes. Shadows stretched, light dimmed. And then, Earth began to vanish. An Earth set. Our planet disappearing behind the Moon. No atmosphere, no familiar horizons, just shadow and silence. And in that moment, everything changed. Distance felt unreal. Scale lost meaning. Even time seemed to drift. As the spacecraft completed its flyby and began returning to Earth, cameras turned once again, this time toward home. And what they captured may be the most powerful images of the entire mission. Earth. Small, bright, alone, floating in an endless black background. But this wasn't just emotional. It was scientific, because these images allow scientists to study how Earth appears from deep space, using modern sensors. This directly connects to one of the biggest questions in science. How do we detect life on other planets? Because when we look at distant worlds, we are looking for something that looks like Earth from far away. Because even small deviations matter, especially for long-duration missions. This is critical, because the path to Mars goes through this environment, and if we don't fully understand it, we can't safely send humans there. Then came one of the most intense phases of the entire mission. Re-entry. After traveling hundreds of thousands of miles, the spacecraft re-entered Earth's atmosphere at extreme speeds. Heat built up rapidly. Temperatures outside reached thousands of degrees. For a few minutes, everything depends on engineering, on calculations made years before launch, on systems that cannot fail. And then, parachutes deploy. The capsule slows down. And finally, splashdown. The mission was over. But what came back was just beginning. Scientists are now analyzing every image, every frame, every signal, looking for patterns, looking for answers, and in some cases finding questions we didn't even know to ask. Because Artemis II proved something important. We are no longer guessing what space looks like. We are seeing it, in detail, in motion, in reality. And this changes everything. Because the next mission won't just orbit the moon, it will land. And after that, we won't just visit, we will stay. The images from Artemis II are not just memories. They are the first chapter of humanity's return to deep space. A preview of what comes next. Because the next time humans leave Earth, it won't be for a mission. It will be for a future.